You think of sleep as the time when nothing happens. 8 hours of darkness, a gap in the day, your body switched off and waiting for morning. That's the opposite of the truth. The moment you lose consciousness tonight, your brain begins the busiest, strangest work it does all day, flushing, rebuilding, rehearsing, paralyzing you so you don't get hurt. You're not shutting down. You're being worked on, and you will never once be awake to see it. We treat sleep like an off switch. The day ends, the lights go down, and we assume the brain powers off with them, idling in the dark until the alarm drags it back. Sleep feels like subtraction, like the day simply stops. But what's actually happening is closer to a second job, one that starts the instant the first one ends. Your brain does not slow to a halt at night. Parts of it get louder. Whole systems switch on that cannot run while you're awake, and they spend the next 8 hours doing things to you that you would never allow if you were conscious. The question is what and why it can only happen once you're gone. For most of history, nobody knew. Sleep looked like a single gray blank, and science treated it that way, until 1953 in a basement lab at the University of Chicago. A graduate student named Eugene Asarinsky was watching a sleeping subject when the eyes, under their closed lids, suddenly began darting back and forth in fast, jerking bursts. He and his professor, Nathaniel Kleitman, woke the sleeper. He'd been dreaming. They had found something no one expected. Sleep is not one state. It has stages, and it moves through them in cycles, roughly every 90 minutes, 4 or 5 times a night. And in one of those stages, the brain burns nearly as much energy as it does wide awake. The blank was never blank. It was a schedule. Once you can see the stages, you can start to ask what each one is for, and the first answer is almost embarrassingly literal. Before your brain can rehearse anything or repair anything, it has to take out the trash. Every waking hour, your brain runs on a furious metabolism, and like any engine that burns fuel, it leaves waste behind. Toxic proteins that pile up in the narrow spaces between your cells. All day, there is nowhere for them to go. Then you fall asleep, and a hidden plumbing system opens up. In 2013, a neuroscientist named Micah Nedergaard at the University of Rochester discovered that during deep sleep, the brain physically changes shape. The cells themselves shrink, and the space between them swells by as much as 60%, opening channels that stay closed all day. Cerebrospinal fluid, the clear water your brain floats in, comes flooding through those channels in slow pulsing waves and rinses the waste away. She called it the glymphatic system, and it runs about 10 times faster asleep than awake. Every night while you lie still, your brain is being washed from the inside, and it can only do it once you're unconscious enough to spare the room. And one of the things that gets washed out is a protein called beta amyloid, the same sticky residue that clumps into the plaques found in the brains of people with Alzheimer's, which means the nightly rinse isn't just tidying, it's protection. In 2018, researchers at the National Institutes of Health scanned healthy people after a single night without sleep and found their beta amyloid had already climbed, measurably after just one missed night in the region's Alzheimer's attacks first. Skip the cleaning and the waste stays. This is part of why sleep was never optional and never a luxury. It's sanitation. But cleaning is only the maintenance shift. While the fluid moves, something far stranger is unfolding deeper in. Your brain is going back over your day, not to relive it, but to decide what to keep. During daylight, every new experience is scribbled down in a fast, temporary place. The hippocampus, a small seahorse-shaped structure that works like the brain's scratch pad. It fills up, and overnight it empties by playing everything back. In the 1990s, a neuroscientist named Matthew Wilson at MIT was recording the brains of rats as they learned to run a maze. Each spot in the maze lit a specific signature of cells. Then the rats fell asleep, and Wilson watched those same signatures fire again in the same order, while the animals lay perfectly still. They were running the maze in their sleep, but not in real time. The replay was compressed, sped up to as much as 20 times faster than the original. The whole day rushing past in minutes, over and over. This is consolidation, the brain copying the day's important lessons out of the scratch pad and into permanent storage, then wiping the scratch pad clean for tomorrow. It's why a night of sleep after practice locks in a skill better than more practice does. The gains arrive while you're unconscious, So while you sleep, you are being cleaned and you're being edited. Last night, something inside your skull went back through everything you did yesterday, chose what mattered, saved it, and let the rest dissolve. You didn't decide what stayed. You weren't consulted. And by the time you opened your eyes, the work was already finished and already gone. There's one more system, and it's the most unsettling of all, because its entire job is to switch you off. When you enter REM sleep, the dreaming stage, your brain does something deliberate and almost violent. It cuts the line to your body. Deep in the brainstem, a cluster of cells releases chemicals that paralyze nearly every muscle you have and hold you completely still. Your eyes still flick. Your heart and lungs keep their rhythm, but everything else is locked down, on purpose, every single night. You are paralyzed in your own bed for hours, and you never notice because it lifts a half second before you wake. And we know precisely why, because we've seen what happens when the switch breaks. In the 1960s, the French scientist Michel Jouvet damaged that exact region in the brainstem of cats, and the sleeping animals rose up, arched their backs, and attacked things that were not there. They were acting out their dreams. In 1986, doctors at the University of Minnesota described the same thing in people, a condition called REM sleep behavior disorder, where the paralysis fails and the sleeper physically lives out whatever they're dreaming, punching, running, leaping from the bed, sometimes hurting the person beside them. The paralysis is not a flaw. It's a cage your brain builds around your body every night to keep your dreams from getting you killed, which leaves the dreams themselves, the worlds your locked body is being protected from. For an hour or two each night, your brain spins up entire realities, fully felt, often charged with emotion, frequently impossible, and then it does something revealing. It refuses to save them. During REM, the brain switches off the very chemical it needs to write lasting memories. So the dream plays at full intensity and is erased almost on contact. Within minutes of waking, more than 90% of it is simply gone. Every night you generate a lifetime of vivid stories meant for no audience at all, not even you. Step back, and a strange shape comes into focus. Every night with you switched off, your brain runs a shift you are never invited to. It washes itself. It edits your memories. It cages your body, and it conjures worlds it immediately throws away. None of it needs you awake. In fact, almost none of it can happen while you are awake, and that is the whole point of sleep. Being conscious is expensive. Paying attention, moving, deciding, it crowds out the deeper machinery. So evolution did the only thing it could. It puts you away for a third of your life so the more important work can run without you in the way. You'll spend around 26 years of your life asleep, not resting, working, or rather being worked on. A quarter of your existence handed over, night after night, to systems you have never met and cannot feel, performing the maintenance that keeps the other two-thirds of you whole. The version of you reading this, the one that decides, remembers, and looks out through your eyes, is not the part that keeps you alive. That part comes out only in the dark, finishes before dawn, and leaves almost no trace. You wake each morning certain that nothing happened. Something always did. So tonight, when the lights go down and the day finally loosens its grip on you, try to hold on to what's actually about to begin. You won't feel the fluid move through your brain. You won't hear the day being sorted and filed and saved. You won't know your body has been quietly locked in place. You'll just close your eyes and disappear for a while. And trust, the way you do every night without thinking, that whatever runs you in the dark will have you back together by morning.